Hello, I am Gonzalez Graciano from the Universidad Tecnológica of Altamira. I'm a student of Mechatronics, 5th-term Group A, and today we have the third practice. And this practice consists of the use of the force cycle to simulate the filling of a thermometer, in this case, and the triggering of the low temperature alarm, and a high temperature alarm. So here we have a thermometer with the scale 0 to 100. We have a numeric control. This numeric is going to be the number of iterations that the force cycle is going to have. In this case 100, because we have here from 0 to 100. This is our index. This is going to be making the count, and is going to be reflected in the thermometer. This component right here is the delay that is going to be half between each of the cycles, scaled 1 and then 200 milliseconds. And the index, we have here 4 comparators. The first two are less equal than, and in this case is going to compare if the value is lower than the 15. That is going to be our set point, and if it's lower, is going to start the low temperature alarm with the corresponding sound. In the other case, we have greater equal than, and it's going to have as well a set point and the index that is going to be compared. If the value is greater than the set point, it's going to trigger the high alarm. So we have here 2 LEDs as usual, but here we have the beeps. These beeps consist in the trigger, that is going to be the value of the comparator, a frequency, and a delay, a duration. The frequency is going to be 500 in order to set a not so annoying volume, and here let's put the same duration as the cycles to see how it works. And alright, so let's give this program a run. As you can see, the beeping sound start from 0 to 15 and then stop, and then we can see that it's filling the thermometer without any sound, and then when it reaches 85, is there again. So we can make this more noticeable if we stop the simulation and increase the duration of the sound. If we increase the duration, it's going to be more noticeable. So let's give it 1 second and give it a run again. We can see that. The problem with this is that this timer prevent from the cycle to repeat it too fast, so we need to wait that 1 second in order to keep this timer running. As we can see here, it's filling faster. This is a good thing in this case because it allows to see the functionality of the circuit more easy. And then again, this happened. We have here a beeping alarm. So the important parts here are the delay between each of the cycles, the number of iterations. We can modify this value. We can set it, I don't know, maybe only 50. And as we can see, I don't know if it's going to work or it's going to wait to the next. Yeah, I have to wait. So let's run it again. And this is going to be the number of iterations. The index is always going to start from 0 to, in this case, 49, because it's the number we set off, -1 because the index starts on 0. And it's going to be compared by the comparators, and then it's going to be sent to the LED and the beep. As we can see, it didn't reach the 100. Let's do this a little bit faster by removing 1 0 from this, and let's run it again. And it's the problem with that is the beeping were more faster than the timer, so we need to time these two carefully. But as an alarm, it serves its purpose. Beeping, 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 stops, then reach the new number of iterations and starts again. So that will be our project.